Okay, we are preparing for SEE examination. In last class, I told you some equations or formula which are related with the numerical problem of the chapter force. I told you 5 different formula. Now, from today, we are going to use one after another this formula. It is written here. I'm going to use this one first to solve the numerical problem. Next class, second one. Next class, third one. This way, we are going to use all these formula related to the chapter force. Okay. Now, look at this one numerical problem. Mass of Sun is 2 into 10 to the power 30 kg and Earth is 6 into 10 to the power 24 kg. Distance between them is 1.5 into 10 to the power 8 kilometer. Calculate the gravitational force between them. Looking at the numerical, usually students get scared, but you don't have to be scared with numerical problem. Whenever we write the mathematical information of the numerical problem, then we can feel it very easy. Look at this. In this numerical problem, mass of Sun is given and we can denote it by m1. m1 is equal to 2 into 10 to the power 30 kg is given. And another mass is given, mass of Earth can be denoted by m2. This is 6 into 10 to the power 24 kg given. And distance between them is denoted by d. This is equal to 1.5 into 10 to the power 8 kilometer. Now in the meantime, I want to mention another matter here. This distance is given in kilometer, but we are using SI system. In SI system, distance should be in meter. That's why I want to convert it into meter. And 1.5 into 10 to the power 8 kilometer can be converted into meter by multiplying it with 1000. 1000 means 10 to the power 3. 10 to the power 3 means 3. 1 having 3 0. 1 having 3 0. This way, it is multiplied by 10 to the power 3 and converted to meter. Now this is equal to 1.5 into, if we have same base here, same base 10, power can be added. 10 to the power 8 plus 3 becomes 11. It is meter. Okay. Now next, the question is gravitational force. Gravitational force is denoted by F, and this is question. Now all the information given in the numerical problem is converted to the mathematical form. Now we don't have to see the numerical problem. We can go through this mathematical informations. M1, M2, D are given. F is question. Now look at equation number 1. M1, M2 and D is given. F is asked, G is missing. Now this G may or may not be given in the numerical problem, but if not given, we have to write ourselves. That's why we can say here, we know what we know. G is equal to 6.67 into 10 to the power minus 11 Newton meter square by kg square. If it is not given, we have to write ourselves. Now after this, we have F equal to G m1 m2 by d square. We are using this equation, and this is equal to, value of G is 6.67 into 10 to the power minus 11 Newton meter square by kg square into, value of m1 is 2 into 10 to the power 30 and m2 is 6 into 10 to the power 24. This is kilogram. This is also kilogram. Now in denominator, what is there in denominator? 1.5. 1.5 into 10 to the power 11 meter and distance is squared. Now, while solving numerical problem, one thing you have to remember, number interacts with number, but power of 10 interacts with power of 10. That's why I suggest you to write number first and then power of 10. This way, look at this. 6.67, another number is into 2, another number is 6 into 6. Now power of 10. 10 to the power minus 11. Another 10 to the power 30. And another 10 to the power 24. What about the unit? Look at this. This kilogram and this kilogram is in numerator, and this kg square is in denominator. That's why we can cancel this. Now remaining Newton meter square. Okay, in denominator 1.5 into 10 power 11 meter whole square means we can write this twice. 1.5 into 10 to the power 11 meter into 1.5 into 10 to the power 11 meter. Now meter square and meter is cancelled. Now I'm going through calculator. Look at these numbers. 6.67 into 2 into 6. This is equal to 80.04. This is equal to 80.04 into, now power of 10 to the power minus 11, and same base we are going to add the power minus 11 plus 30 plus 24 Newton. And in denominator, what is left in denominator? 15 are 225. After decimal point, there are 2 digits. That's why I am taking decimal point here. There are 2 digits into 10 to the power 11 plus 11. This much. Now 80.04. We have 80.04 divided by 2.25. This is equal to 35.5733. I am taking just 2 digits after decimal point. 35.57 or F is equal to 35.57 into, look at this, 10 to the power 11, this 24 plus 30 equal to 54 minus 11 equal to 43. 10 to the power 43. And in denominator what we have? It's already gone. 10 to the power 22. 10 to the power 22. Now in next step, I want to tell you something more here. Look at this. Normally we take decimal point after 1 digit. But here it is after 2 digit. That's why we have to shift this decimal point to left hand side. And there is a rule. I want to tell you that rule. Just for example, if you have big number 2, 5, 7, 3, 8, 2, let's say this much big number. If you want to express this number shortly, then you can write this way. The decimal point is here. It can be shifted to this place, and you can write 2.57382 into how many digits it is shifted to left hand side? 1, 2, 3, 4, 5. We can multiply it with 10 to the power 5. This number and this number is equal. These two numbers are equal. And after decimal point, if you want to take only 2 digits, then you can ignore this. This way, we can reduce this number to this. In the same way, there is another also. Look at this. 0.003572. If this number we have to reduce, then point can be shifted to 3 digit right hand side like this, and we can write 3.572. But point is shifted to 3 digit right hand side. That's why we have to multiply with 10 to the power minus 3. If point is shifted to right hand side, power of 10 should be negative. If point is shifted to left hand side, power of 10 should be positive. In the same way, here also we are doing the same. Point is shifted to 1 digit, that's why 3.557 into 10 to the power 1 digit shifted to left hand side, into 10 to the power 43. Here Newton, I left to right. Okay, this is this. Now this in denominator we have 10 to the power 22. If it is taken to the numerator, then the same becomes 10 to the power minus 22, and the unit Newton is at last. Okay, or F is equal to 3.557 into 10 to the power 1 plus 43 plus minus 43 minus 22 Newton. Therefore, lastly what came? F equal to 3.557 into 10 to the power 43, 44 minus 22 becomes 22 Newton. This is our last answer. What is the gravitational force between Sun and Earth? It is 3.557 into 10 to the power 22 Newton. Today I focused on first equation. Next class we'll use second equation.